Wi-Fi Sheep would like to say a huge thank you to all of you that kindly support us. Help us continue to bring new videos like this. Join patreon.com/Wi-Fi Sheep from just $1 a month. Hi, how you doing? And a very warm welcome back to youtube.com/Wi-Fi Sheep with me, Tom. Now, an article caught my attention recently. It was actually posted on one of the basic interpreter fan groups on Facebook, and it's an article from medium.com. I'll bring it up on screen for you now. Links are in the description. Basically, this article is entitled ESP32, a look at the built-in basic interpreter. And I'll just paraphrase for you. The article was written in 2020 and basically suggests that every ESP32 microcontroller actually has a hidden built-in basic interpreter, and to be precise, TinyBASIC. Now, if you're a fan of the channel and follow my work regularly, you'll know that I've been doing a long-running project called TinyBASIC Computers, which is basically consisted of me trying to get a working basic interpreter running on Arduino AVR microcontrollers. And we have it working relatively well, and those of you that follow the project will know all about it. However, the idea that the ESP32, that's a 32-bit microcontroller system from Expressive Systems, actually has TinyBASIC already built in, etched into its ROM, and every microcontroller has this on board, I got to be honest with you, I'm a little skeptic of that. So I have plenty of random ESP32 microcontrollers to try. So I thought, let's see what this says. Let's recreate the experiment and let's find out what happens. This video is sponsored by PCBWay.com, offering services such as 3D printing, injection molding, CNC machine tooling, sheet metal fabrication, and of course turnkey PCB manufacturing. Take a look at PCBWay.com/projects and all the amazing things people are creating with PCBWay's wide range of production tools and services. Sign up for your free account today at PCBWay.com. Details and links are in the description. So whenever you try and do anything with ESP32s, and I've got one here, there's always a slight problem, and that is trying to get them to fit any prototyping or breadboards, because the boards are actually quite wide. Some of them are actually wider than this, so even in the best case scenario you normally only get one pin side actually available, so it's very difficult to tap either side of the pins on a standard breadboard. That's why I'm referring back to these. You might remember these are the Motojuno Lab ESP32 development kits we featured on the channel a little while ago. Link for that should be on screen now. These were from techdesign.com, and basically it gave you a little dev board package kind of like this. Make sure we get that the right way around. And these are ideal for testing with ESP32s. It also came with an ESP32 per package, which I wasn't expecting at the time. Now, heading over to the medium.com article, it talks about the idea that you have to bridge pin 12 or P12 or D12, depending on which board you've got, to 3.3 volts. Well, you'll notice on this one, the pin out is not printed on the top of the silkscreen. I have another identical board here. It's actually on the underside. You can just make it out there. It's really, really tiny. So we want to bridge, in this case, P12. Let's see if I can find that. Yeah, that should be 7 along. So 1, 2, 3, 4, 5, 6, 7 to 3.3 volts, which is up here. So when you flip that over, it's the top here. Now, according to the article, what that should do would generate an error in which the ESP32 is going to go into some sort of recovery mode, and according to the article, should load the pre-installed hidden version of TinyBASIC. Again, I'm very skeptical about this, but let's find out. So to test it, I've got one of the USB cables. Again, these actually came with the kit because they have the micro USB end that's required for the ESP32s. So I'm going to pop that in there, and then just off camera here, I've got my Orange Pi 800 all-in-one system. that I featured on channel. Again, I'll link to that as well if you're interested. And we're just going to pop the USB for that in. So this should, there we go, it should power up the board. Okay, so if we cut to the Orange Pi, here's the Linux desktop. So this is Ubuntu XFCE, and I set up some minicoms here. So you need minicom installed. Okay, that's now talking via serial to the ESP32, and you can see we've generated an error. Now, if I hit reset, you'll notice that instead of giving me the hex error, it's now stopped and is waiting for download. So that's where the article says you should get to, and at this point it should tap straight into a TinyBASIC. Alas, there's nothing there. I can't make that work. Yeah, so I think there might be an element of truth in this, but not on this particular dev board. Okay, so maybe it's this particular brand of ESP32 that's the issue. I don't know. This one is a slightly different make. It's a slightly different size, slightly different pin out as well, which means I don't think it's 100% compatible with these boards. I'm not sure. But what I thought we might try with this one is we'll try the same bridging trick and see what it does. And I've got here a jumper wire. This one's actually got the silkscreen numbers on the top, which makes life a little bit easier. But let's try and bridge. These are labelled as D, not P. And I'm just looking for 12. D12, which is there. And we'll bridge that to 3.3 volts, which is over here on this board. So what I mean about the pin out is totally different. So I bridge like that. And then we just disconnect. Let's take our 10k ohm resistor, and I'm just going to bridge, and that will make quite a crude circuit, but that should work. So let's power this up. Okay, and let's take a look back. Let's check if you've got Arduino IDE installed, which on this I have. Let's open that up. And let's have a look at, first we'll make sure we're looking at the right port. Let's take a look at our serial monitor. Let's just see what we're running at. Is there anybody home? Ah, there we go. So you can see here it does exactly the same thing. It has a read error, so that's now working. We know what the baud rate should be. So let's see if Minicom will talk to it again. There we go. And I can't input anything. And apparently, according to the article, that should load into TinyBASIC. And as you can see, it doesn't. It's slightly different, but there's still absolutely nothing there. So pretty much as expected, I tried two different brands of ESP32 microcontroller. And yes, we can make the memory map crash. And we can bring up error messages via serial terminal. But as far as I can see, there is no basic interpreter preloaded on any of these microcontrollers. So I don't know if this is simply not true, some sort of hoax. I did think, is the article from April's Fool's Day, but it's actually dated May the 2nd, 2020. So it's a little bit late for a wind up. Or does this only work on a certain type of ESP32 microcontroller and in none of the brands I actually have? It doesn't seem to make any difference, regardless if it's a used ESP that's had some flash to it, or if it's a new one. It doesn't seem to matter. There just isn't a basic interpreter there. So it was an interesting experiment, but yeah, we've kind of fallen a bit flat on that one. Okay, one final last-ditch attempt I was thinking about was possibly, could we try it with this, which is a slightly older ESP microcontroller known as the ESP8266. And I thought, yeah, we could try that. And I was looking for D12 on this, and it doesn't even have a D12 that I'm aware of. So I don't think that's going to work either. If you know different, then do let me know. But from the looks of it, I'm not saying it's not untrue, but I certainly can't replicate with these boards. So it's not true that there's a hidden TinyBASIC interpreter on every ESP32 microcontroller. That might have been the case a couple of years ago. It's certainly not the case with any of these, but I can make happen so far. If, however, you do want to try TinyBASIC on a microcontroller, you can, and we did a video on this. Wasn't with ESP32, although I believe there are some versions available for ESP32 if you search online. But I tried it with Arduino Nano, which is one of these. This will also work with the Uno or the standalone Atmega 328P IC if you wanted to try it. And we did a whole video on how you can actually run a TinyBASIC interpreter, again using a serial module and Minicom on your Linux, or PuTTY if you're on Windows, and you can actually run a real 8-bit basic interpreter from one of these chips. Again, links to that are in the description of the video, so do go and check out that video if you're interested in actually running TinyBASIC on an Arduino microcontroller, something that will actually work. As ever, if you haven't done so already, please do consider liking and subscribing to us here on Wi-Fi Sheep, and I hope to see you real soon right here on the channel. Until next time, bye for now.